Hello and good morning, students. So, in this class, we'll continue our discussion on acid, base, and salts. So, up to our last class, we have discussed about what are acid and their sources, their effects. In today's class, we'll mainly discuss about base and their different characteristics and other features. Okay. So what are base? First of all, in the last class, as I told you, we can classify different things into two groups based upon their taste, whether they are acidic or basic or neutral in nature based upon their taste. Acid will have a sour taste. At the same time, soda will have a bitter taste. Bitter means karva taste. Okay. So, if you have ever tasted baking soda in preparation of cake, then your bread, okay, biscuits, people use baking soda. So, if you have ever tasted baking soda, the taste of it will be bitter. That means kadwa, or the soap by which our mother or in home we used to wash clothes. Okay, the local soap. Okay, these soaps or if you taste these soaps ever, you will find that the taste will be bitter, kadwa in nature. Okay, so we can classify base as the substances those will have bitter taste. The substances that are bitter in taste and they have soapy touch. Soapy touch means if you touch them, you will feel slippery, right? If you touch a soap, you will feel it as slippery substance. So the characteristics of base are it will taste as bitter, that means kadwa, and it will have a soapy touch. Okay. So if in exam comes, write some example of bases, then you have to write the examples as written here. The first is sodium hydroxide. The chemical formula is sodium hydroxide NaOH. Na for sodium and hydroxide is OH. Then the next is potassium hydroxide. K is for potassium and OH for hydroxide. Okay. Then calcium hydroxide. Ca for calcium and hydroxide means OH. Magnesium hydroxide MgOH. That means wherever you find OH group with any other group, you will say that it is a base. For example, see in all these NaOH, KOH, CaOH2, MgOH2. In every case, we are getting a OH group. So the presence of OH group indicates it is an acid or base. It is not an acid, it is a base. Okay. Moving to the next, here we have some common bases and their sources. The first base is calcium hydroxide. So from where we get it? Calcium hydroxide from lime water. Lime means chun. In common language we call lime as chun, right, which people used to eat with pan. So calcium hydroxide we get from lime water. Then the next is ammonium hydroxide. So from where we get ammonium hydroxide? From different cleaning sources such as window cleaner. You have seen that there is a name of the window cleaner is Colin. People used to clear window glasses with this chemical sprays. Name is Colin in market. They are known as window cleaner. Then floor cleaner. There are different cleaners, chemical cleaners used to clean the floor tiles of our home. So these are known as floor cleaner. Then wood polish. So these things contains the chemical base name is ammonium hydroxide. Then in soap whatever you use at home, we get two types of bases. The first is sodium hydroxide NaOH. Next is potassium hydroxide. Sodium hydroxide is NaOH. The next one is potassium hydroxide, that is KOH. Okay, remember this formula. You have to write this formula in exam. These are very important. Okay. Then the next is we get from antacid. Then cosmetics, different type of cosmetics. What mainly women use these cosmetics. Okay, toothpaste. Then ointments. Different ointment means different medicinal ointments. Okay, we get this magnesium hydroxide MgOH2, MgOH2. This also we get, this base also we get in these things such as antacids, cosmetics, toothpaste and ointments. Okay, sorry. Next is neutral substances. So by the name, as the name suggests, neutral, what does the neutral means? Not this side, not that side. Okay, it is in between. That means neutral substances are those substances that are neither acidic nor basic. You cannot consider it as acid or it as base, it is in between. For example, pure water. If you drink water, you know that water is tasteless. You will not find sweet, you will not find sour, you will not find any bitter taste in water. Water is tasteless. That means water is neutral. Then glucose, urea, salt, then sugar, these all are examples of neutral substances. So to be very clear, if in exam it comes what is neutral substance or neutral things, you will answer it. The substances which are neither acids nor base are known as neutral. For example, water. Water neither taste bitter nor taste sour, so it taste it is not taste, so it is known as neutral substance. The next point is very important for your exam point of view, that is indicators. So what are indicators? I think this point is very clear to you, but as this is YouTube class, you cannot respond. I understand that. So, what are indicators? For example, um, we are classifying what acid and base. So, as I told you, if you taste lemon, you will get a sour taste. So, you will say that okay, lemon contains acid. Or if you taste your soap, then you will get a bitter taste, that means karva taste. You will say that sir, it is a base. That means to check whether acid or base, you are tasting it, right? You are taking it into your mouth. But as you know from very childhood that we cannot eat everything, right? For example, in forest you are getting a seed and you want to check that this plant seed contains acid or base. Will you taste it? If you don't know whether this seed is poisonous or not, no, you will not, because the seed may be poisonous. The acid which you want to taste, it may be very dangerous, it may be deadly, you can die also. So to check whether acid is a substance is acid or base, you cannot always taste it, you cannot always take into your mouth. So you need a system, a mechanism, a machinery, okay, a test procedure by which you can check whether it is acidic or basic without taking it into your mouth. So indicators are substances by which we can check whether a substance is acidic or basic. So very interesting is this. Okay, this is not new, just to remind you, I am showing you this point. They are giving you a question that do not taste anything unless asked by your teacher or elders. So very beginning of our childhood, we are taught about these things, that do not touch anything or do not eat anything which is not told by your guardian, parents or your teachers or elders to do so, right? If you find any unwanted object in the road, you will not touch, right? Because it may be a bomb, it may be a poisonous thing. Similarly, you will not eat anything given by anyone or any unwanted thing found in somewhere, because it may be poisonous, it may be deadly. So always remember these things, and you should teach these things to your siblings, right? Younger siblings. So what are indicators? Indicators are special substances that give different colors in acidic and basic mediums. Okay, they are the substances which will give different colors on acidic or basic mediums based upon the presence of different groups, and based upon different colors they will produce, we can classify whether it is an acid or a base. So the question comes, how do indicator works? What is the mechanism? Why they change color? When indicators are added to a solution containing an acid or basic substance, they change their color. Okay, turmeric litmus, okay, then turmeric litmus, china rose, okay, petals, and red cabbage juice are some naturally occurring indicators. Phenol, phthalein, and methyl orange are some examples of human made indicators. So how indicators work? Basically they have certain color. For example, litmus, for example, it is of red color. So if we add it to acid or base, it color will change to blue or some other color. Okay, that means by changing the color, it is indicating you something. For example, I am normal today. So if I am doing your class, what you will understand, okay, sir is normal. But today what I am doing, repeatedly I am coughing, right? I am sneezing and coughing. So you'll understand that, okay, sir is not well, sir is suffering, probably sir is suffering from fever. So my cough and sneeze is indicating you that I am not well. Similarly, in this case also, the paper, litmus paper, is originally of red color, but as soon as you will dip into acid or base, it will change its color. So the sudden change from red to some different color will indicate your mind that it is not the same thing, it is either acid or base. So based upon this color, we can differentiate different things. Examples of some indicators are turmeric, then litmus, china rose petals, okay, red cabbage juice. These are natural indicators. These are naturally occurring indicators. So some human-made indicators what we have made, examples are phenolphthalein, methyl orange. These are examples of human-made indicators. Okay. So the first indicator we'll study, and the very important, we'll get this, it's for sure in exam. You can give a star mark in your book also, and not only in exam, in your higher class, class 8, 9, 10, 11, 12, whenever you'll study science in your higher class, you'll get this point, the litmus paper, red or blue litmus paper, you'll obviously will get it. Okay, so this is very important for your exam. The most commonly used natural indicator is litmus. Okay, what is litmus? It is a dye extracted from lichens. So what is litmus? It is a dye which we get from where? From the lichens. The solution of litmus is distilled water. Okay, water is mauve, purple in color. The solution is neutral litmus solution. Okay, how does this litmus solution work? So we'll learn about this in next slide. So in this slide they are just giving an introduction of litmus. From where we get litmus? From lichens we get litmus. Generally when you extract the litmus dye, it is purple in color. Okay, and it is neutral in solution. Litmus is having no acid character, no basic character. Okay, it is neutral. So how does it work? We'll learn this now. The first thing is, when litmus solution added to a acidic solution, it turns red, and when added to basic, it turns blue. So litmus is generally purple in color, it is basic. So if we add it to acidic, what will happen? It will become red in color. And if we add this litmus into blue, it will become, sorry, if we add this into base, it will become blue in color. So from purple, if acid, it is becoming red, and if base, it is becoming blue. So it is giving two different color for two things. So if the color is red, we'll say it is a acid, or if the color is blue, we'll say it is a base. So based upon the color, we can differentiate between two. When neutral solution is added to the neutral, okay, to the litmus, it does not change its color. So it's obvious, when you will give neutral solution, it will not change any color. If it is acid, it will become red. If basic, it will become blue. So remember this, not for exam purpose, for throughout the life. This is very important. Litmus is neutral in nature. It is having purple color. If we add acid to litmus, it will become red. Acid means red. Acid red. Acid red. In this way, remember. Okay. And base will become blue. Base blue. Base blue. Okay. And if neutral, and for neutral and for no color, acid is red is dangerous, so acid is dangerous, so acid is red. Blue is less, basic is less dangerous, so basic is blue. Before basic, before blue. Okay, Litmus solution is available in the laboratory in the form of red litmus solution and blue litmus solution. To make litmus solution, a few drops of base is added to neutral litmus solution. Okay. So how this acidic and basic litmus solution is prepared? So if you want to prepare red litmus solution, what you will do? With the neutral solution, you will add few drops of acid. If you add acid, it will become red. So red litmus prepare, right? If you want to prepare blue litmus solution, how will prepare? Take neutral, add base, it will become blue. Very simple. So this is all about your litmus solution. Okay. So this is a very easy diagram to make you understand. See, this is acid, right? In this beaker we have acid. You are dipping blue litmus paper, but actually the color is blue because here we have base in this. But as soon as you are dipping it, it will take the acid and it will become red. As I told you, red is dangerous. Red is acid. So red means it contains acid. Acid turns blue litmus red. Next, see, it was red actually, but as soon as you are dipping into base, it is becoming blue. Blue, B for basic. So base turns red litmus into blue. I think now it is clear. If acid, it will become red. If base, it will become blue. So this is for today. From next class we will discuss there are different other indicators such as turmeric and your other natural indicators are there. So today up to this much. In next class we will discuss further. Thank you students.